Hi there, this is Jags Ramnaran again. So now we'll go through part 2 of the demo. Um, so in this part of the demo, we'll look at how to achieve interactive analytics where the data is in fact changing. So we use a technique called as CDC or Change Data Capture. For those of you who haven't heard this term before, this essentially refers to the technology that can capture transactions as they happen in databases, and it can route it to one or more endpoints. It's typically a use case for this would be to replicate databases essentially. Okay, so before we dive into this, let's actually revisit and refresh our memory on the problem we went through for demo 1. So like you know, all new data is often emerging to customer facing apps and captured as transactions in operational databases. From there, you'll end up going through classic ETL to other analytical databases, applying transformations. And if you're going to operate in the cloud, the data has to be periodically copied back out to the cloud. So like I said before, this is a fairly expensive process, very time consuming process. Often the data you're analyzing is stale, and so your insight essentially is also stale, right? So what we really want is to be able to capture changes as they happen and be able to route it to our analytical storage, right? So the most common choice today is to inject a message bus like Kafka into the application pipeline. And as you can see, I'll just talk through this. It's rather very difficult. So here is a typical streaming pipeline that you potentially see today. One example, I mean, there are many variations to this obvious architecture, right? As your application microservices, let's say, transacts with a database, say in this case Amazon RDS, your application might also route events to Kafka. Then the Kafka messages would have to be decoded by either using Spark Streaming, Flink, or you can substitute your favorite stream processor. And then finally write it out to your analytical store. If you're operating in the cloud, maybe you're writing it to S3, formatted in Parquet, or maybe you're just writing it out to a traditional warehouse like, let's say, Redshift. Well, there are a number of challenges here, right? First, well, how exactly can we achieve consistency if we're going to write as transactions happen both to Kafka as well as to our database? To essentially achieve consistency, you have to worry about two-phase commits, you have to worry about various failure conditions. And moreover, what happens if you land up changing the schema in one? Well, you have to consistently land up changing the schema in other, else you again land up having potentially inconsistent data in our analytics store. And finally, you have to write code that has to decode data objects from Kafka. Maybe the data was formatted as JSON, and storing it with consistency to your analytical store, which is again your responsibility. So the other challenges have to do with when failures happen, you might land up having the messages delivered twice. On top of that, if the events land up being DML events like updates and deletes is rather very complex. So instead, what we're really proposing is using a design where your application essentially only works with your operational store, and you use CDC technology to capture the changes in real time in a transactionally consistent manner, and just keep pushing the delta continuously to our essentially Snappy hybrid store. So it's a rather much more simpler, far fewer sort of pieces that can break, and even if anything breaks, everything can recover fully in a consistent manner. So the way we essentially accomplish this in our cloud platform is by deeply integrating with an open source platform from Red Hat called Debezium. It's really designed with using Kafka Connect. You can go check out debezium.io for a full understanding of what it does. But we have landed up essentially deeply integrating. So as I'll show you, this requires no application coding other than simple Spark-based transformation. If your schema that you use for analytics lands up being different than what you have in an operation store. I won't be getting into details of how exactly all this works. But one important point to note is that the CDC engine uses Kafka Connect to tap all the committed transactions in let's say if you're using MySQL and sort of bin log, and that's what gets pumped to your destination. So essentially what is guaranteed is that you only see things that have in fact completely been committed in your transactional store. And you essentially land up maintaining source ordering, which is a big plus compared to, let's say, if you land up just using Kafka. All right. Let's just revisit the demo architecture from before. In part one of the demo, we showed you how to load data from Mongo, static data from S3, in for schemas, run interactive analytic using notebooks, and also we showed you how to run analytics using a BI tool like Spotfire. So we landed up using, you might recall, the airline on-time performance data, about 200 million records is what we landed up analyzing. In this case, we just introduced a few additional components. We use MySQL to simulate our transactional database that's being continuously being written into from a customer-facing application or microservices. And then we essentially run Debezium that's capturing these events and routing it to Snappy. All right, so let's take a brief closer look at what the demo is doing. We simulate an application by continuously writing records to a MySQL table called airline perf now that you see here on top. The transaction log, which is really bin logs in MySQL, are continuously watched by Debezium, and Debezium internally essentially is based on Kafka Connect. The events are then formatted into JSON and written out to topics in Kafka. But default, each table, if you sort of say, hey, here is a complete schema in MySQL you want to monitor, each table would have land up having its own one associated distinct topic in Kafka. Then inside SnappyData, we use a component which we call CDC ingester that continuously reads from Kafka, understands natively this Debezium formatted messages, transform these back out as rows, and writes it in a highly efficient parallelized manner to our target column table. Of course, the whole chain is protected from failures and guarantees that any writes that happen all the way are made idempotent. In other words, we guarantee consistency of all changes happening in MySQL and how those changes will emerge in column table. All right, so let's get right into our demo here. So first, let me show you guys my Kubernetes cluster. So as you can see, we went from a cluster of size 3 to size 4, a very small cluster. Here are all the workloads, essentially pods that I'm running. As you can see, I've started a couple of new pods. I'm running MySQL 5.6, in a single pod. We are also running Kafka, and Connect MySQL is really Kafka Connect running Debezium, which is in turn connecting connecting to MySQL, writing it out to Kafka. And you might recollect all the other Snappy services that we walked through in our previous demo. All right, so there are basically, when it comes down to the demo, there are really, once your infrastructure is set up, which basically means Kafka, Debezium, and SnappyData is running, all you really have to do is primarily essentially two things to stream our real-time events all the way into our analytics store. First, we configure our CDC connector to monitor MySQL. And the second is you configure the CDC ingester I talked about in SnappyData to stream our Kafka events and publish to our column store. So, okay, so let's see how do we do both of these things. So once Debezium is running, you can essentially use a REST API, and this is the REST call that essentially says, hey, Debezium, I want you to monitor my MySQL database, use these credentials, here's a server. And the database whitelist essentially says, I want you to use the database called inventory, and essentially it's monitoring any tables that emerge or changes in inventory, and then it's going to route it to, in this case, a Kafka topic called, dbhistory.inventory. Okay. Well, so I'm just trying to run it, but I actually already have started the Debezium connector, so it's already listening on that specific schema in MySQL. So that's as simple as setting up Debezium. We're already set up to kind of monitor any changes that are happening. So very quickly, let's take a look at how do we set up our stream ingester in SnappyData. As you might recall, SnappyData, this is a dashboard. I think I went over this before. We're running essentially 3 data servers in SnappyData, and let's actually see if we can get our ingester working. So the CDC ingester is just set up as a notebook, and it actually runs as a Spark structured streaming program inside of SnappyData. And here all you essentially tell us is, the list of Kafka brokers, the Kafka topic you want to listen to, and then the target table that you want to ingest into. And for streaming, you need a checkpointing directory. So in case there are failures, we are able to make our entire streaming pipeline to be idempotent, right? So let's just run this paragraph. So it sets up our configuration. Then the very next thing we do is we start, and let's actually see if our ingester is running or stopped. So the print status tells us that the ingester is in fact stopped. We'll start the ingester, which will take a few seconds to get going. It's a fairly straightforward structured streaming program, and also lands up using the Snappy sync, so that it's making sure that anything that's coming to Kafka lands up inside our Snappy tables. So looks like our ingester is up and running. Let's make sure it is in fact running. So as you can see, it's waiting for our next trigger. All right. So the final step in our process is to literally go and write something out to our MySQL database. So let's just do that. All right. So let me connect to my MySQL pod using kubectl in Kubernetes. So I'm going to log into the MySQL shell, and I'm going to switch to this database. So if you go show tables, you should see a bunch of tables. So what I'm going to do to simulate continuous writes to our operational table, in this case, we're going to use this table called airline performance now. It's equivalent to saying that all the aircrafts are landing, we are essentially capturing its on-time performance, and those records are being continuously, we're simulating as if those records are continuously arriving to our MySQL database. So we're going to keep it simple, and what we're going to do is we're just going to simply write into our store by simply capturing a bunch of events in another table. So this is essentially simulating continuous writes. So that's what we'll end up doing. So we'll just say, hey, let's just continuously write into this table, and the idea needs to be to figure out whether these changes continuously land up arriving into our column table, right? So as you can see, this is the table. And as you can see, it's already started to grow. It's now up to 28,000 records. And if you go back to our ingester program, we can print the status again. As you can see, it's saying it's processing new data as it's arriving. All right. So finally, we have new data continuously arriving as it's arriving to MySQL into our column store, so it should be ready for analytics. So here is a very simple example where we essentially compare historical on-time performance. So essentially looking at arrival delay for large airlines, from our historical store. So we run that query, and then of course we can say, hey, this is the same, pretty much the same query, but just going on this airline performance now. So of course the records are building up. So obviously, as we run this, we might see different results as we keep running it. So as you can see, there is still no data for WN, which stands for Southwest Airlines. So if you keep running it over time, we will essentially see that data too. All right. So I guess I showed you how we set up Debezium, how easy it was to start Debezium monitoring MySQL. How did we route it into Kafka? From Kafka, how did we pick it up very easily just by running that ingester into SnappyData. So with that, let me just go back to my, let's just summarize real quickly what we did. So in part one, we really went through showing you how easy it was to connect to any data source in parallel from S3, Mongo, any SQL database, and how we'll end up pulling up the right data sets into distributed memory. We showed you how easy it was, where we didn't really use any data pipelines, no ETL. We showed you how fast it was compared to Spark. And then finally, in this part of the demo, we showed you how easy it is to capture changes on any source database. In this case, Debezium actually supports about 5 databases today, and we're planning to add more to capture CDC changes, and we showed you how to route it into Snappy so that we can do real-time analytics. So with that, I encourage you to go check out our website. Of course, SnappyData as a project is an open source project, free to download, try it out, give us some feedback.